For section 3.3, we are going to prove that lines are parallel. So before we get started, I want to review what a converse is. And the converse is found by switching the hypothesis and the conclusion of our statement. The converse is not automatically true, but if it is true, it must be stated as a postulate or provided as a separate theorem. So that moves us into the converse of the corresponding angles postulate. And what this says is that if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then this proves that the two lines are parallel. So in the picture, angle 1 and 2 are congruent. So this proves that line M is parallel to line N. So if the corresponding angles, remember they're in the same spots but on a different line, if those angles are congruent, are the same measure, then we can prove that those two lines are parallel. So with that being said, we are going to have to use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. So I need to draw my picture here first. So they have given the information that angle 1 is congruent to angle 5. So this angle is the same as this angle. So that piece we know is true because these are corresponding angles. And if corresponding angles are congruent, then we can prove that the two lines are parallel. So line L is parallel to line M, given this postulate up here, because that's exactly what it said. So this postulate is called the converse of the corresponding angles postulate. So just by knowing those two angles, we know that those two lines are parallel. So for part B, we're going to have to get our picture drawn here. This one is telling us that the measure of angle 4 is 2x plus 10, and that the measure of angle 8 is 3x minus 55. They are also telling us that x is equal to 65. So I can plug what I know in. So the measure of angle 4 equals 2 times 65, since they told us x was 65. If I do that, 2 times 65 is 130, and 130 plus 10 would be 140. And I did that using substitution because I just replaced the x with the 65. And I'm going to do the same thing for the measure of angle 8. We're going to do 3 times 65 minus 55. And 3 times 65 is 195. And if I minus 55 from that, I have 140 as well. And we did this using substitution, as we plug that 65 in for x. Now, what we can see is they're both equal to 140 degrees. So we can say that the measure of angle 4 equals the measure of angle 8. And that is because of that transitive property of equality. So if we know something and we use that to figure out that two other things are equal, then that's the transitive property of equality. And then from there, if those two angles are equal and we look at this picture, they're corresponding angles. So I can say that angle 4 is congruent to angle 8, and that's based off of the congruent angles definition. And if those are congruent or equal, then I can say that the line L is parallel to line M, and that is using that postulate from up above, the converse of corresponding angles postulate. So that's because of the converse of corresponding angles postulate. And that's what they wanted us to prove, that those two lines are parallel. All right. Now we have a parallel postulate. It says through a point P, not on line L, there is exactly one line parallel to L. So if I have line L and I have a point P that's not on that line, I can only draw one line through point P that's going to be parallel to L. So I can only draw a line like that. I can't have it on an angle because they're going to end up crossing line L. So something you've already known, but now it's as a postulate. So we're going to have to use that later on. And then we have a few theorems here, proving lines parallel. The first one is the converse of alternate interior angles. Remember, alternate interior on the inside of the parallel lines, but on opposite sides of the transversal. So if those are equal, then that proves that M and N are parallel in the picture. If alternate exterior angles, so exterior is on the outside of our parallel lines, and alternate means on opposite sides of the transversal, if those are equal or congruent, then we can prove that the two lines M and N are parallel. And then the same side interior. So if they're on the same side of the transversal and they're on the inside of our parallel lines, and they add up to be 180. So same side interior have to add up to be 180 and be on the inside of the parallel lines and on the same side of the transversal. That's a lot right there. If that's true, then we can prove that M and N are parallel as well. So for example 2, we're going to use this given information and the theorems that we have learned to show that R is parallel to S. So this one is given that angle 2 is congruent to angle 6. So here is 2, here is 6. Those are on opposite sides of the transversal, so those are called alternates. Interior, because they're in the middle of our parallel lines, so interior angles. And if those are the same, which it's telling us that is, then we can say that R is parallel to S. Based on, we got to go back up here and figure out which one was the alternate, the converse of alternate interior. Angles theorem. Okay. Now we're going to use the same picture and we're going to use this information given here. It says the measure of angle 6 is given there, 6x plus 18, and the measure of angle 7 is 9x plus 12. And they're telling us that x equals 10. So 6 and 7 are right here, this one and this one. So those look like same side interior angles. They're on the same side of the transversal and on the inside of our parallel lines. But we are going to do some substitution here. X is 10, so we're going to replace the measure of angle 6 is equal to 6 times 10 plus 18, which would be 60 plus 18, so that's 78. And that is substitution because I just plugged in the 10. And the measure of angle 7 is 9 times 10 plus 12. So that would be 90 plus 12. And 90 plus 12 is 102, and that is because of substitution. And then if we look at those two angles, if I added the measure of angle 6 plus the measure of angle 7, I would get 180. And that's because they are same side interior angles. And if those angles on the same side interior equal 180, then we can use that converse of same side interior angles theorem to prove that R is parallel to S. So the converse of same side interior angles theorem. And for example 3 here, we also need a picture. For this example, we are given that line L is parallel to M and angle 1 is congruent to angle 3. And we need to use that to prove that R is parallel to P. So we're going to start off with what's given. L is parallel to M. So that is given to us. If that's the case, if L and M are parallel, then these two angles right here, 1 and 2, are going to be congruent. So angle 1 is congruent to angle 2. And that is because of corresponding angles, because they are on the same sides of that those parallel lines, L and M, that we were given. We were told those were parallel already. So corresponding angles, postulate, I think that's called. And then we're also told that angles 1 is congruent to angle 3. So that's something that was given to us. So 1 and 3 are the same. And those are alternate. Nope, they're not. So from there, we have to look at our picture. If 1 and 3 are the same and 1 and 2 are the same, that means that 2 and 3 are the same as well. We weren't given that piece of information. So angle 2 is congruent to angle 3. And then that's that transitive property of equality again. If we know that two different sets of things are equal, then we can mix and match in those sets with they're all being equal. So transitive property of equality. And then if angles 2 and 3 are the same, if you look, they are alternate exterior angles of P and R, then that tells us that R is parallel to P because of that converse of alternate exterior angles theorem.